Hi guys, welcome back to our mathematics tutorial, and my name is Peter C. Dr. Jr., your math tutor. In this lecture, we will be discussing formation of differential equations, and in previous lectures, we did few problems involving families of curves and how we can form a differential equation. So we want to continue with that same type of problems that has to do with finding the differential equation of a family of curve. So this question number 8. Find the differential equation of a family of curve y equals to a cos of mx, okay, this is mx, plus b sine of mx, where mx fixed and a and b are the arbitrary constants. So again, we told you when you have an equation to form a differential equation. So basically that equation is normally the solution of the differential equation. So if you want to form the differential equation, the first thing you must identify how many arbitrary constants do you have in the problem. So the number of arbitrary constants determines the number of times you're going to differentiate. So since we have two arbitrary constants, it means we must differentiate twice. So we have y equals to a cos of mx plus b sine of mx. So we differentiate the first time. We have y prime equals, so we have a, differentiate cos of mx is just minus sine of mx times the derivative of mx, which is m, plus the derivative of b sine of mx is just b cos of mx times the derivative of mx now, which is just m. So we can further simplify. We have negative a m sine of mx, and then plus bm cos of mx. So we find the second derivative, y prime prime equals to, now so these are all constants, so you have minus am, we differentiate sine, we get cos of mx times the derivative of mx is just m, plus bm, we differentiate cos, we get sine of negative sine of mx, so times the derivative of mx now is just m. So if we simplify this expression, we will now have m times m to be m squared cos of mx, and then this negative comes outside, you have minus b m squared sine of mx. So if we compare this equation with equation 1, we see that we have in equation 1 we have a cos of mx and b sine of mx. Also here we have a cos of mx, b sine of mx, but there are other stuff that are attached to it. So we can factor out negative a. So we need, remember we need this form. So it's a cos of mx, a cos of mx. So we just need to factor out m squared, because m squared is here, m squared is here as well. Negative and negative, we can factor it out. So we'll be left with a cos of mx plus, so use this one, plus d cos or sine of mx. So we factor out negative m squared in both terms. So therefore we know that this entire expression is just equal to y. So y prime prime equals minus m squared y. So what do we need? We need to find the differential equation, but we don't need an arbitrary constant, which is m, within that differential equation. So we must get rid of it. How do we do it? We can solve for, now we have the first equation, which is this. We have the second equation now that we just derived at, which is this guy. So we can be able to solve for m squared and derive at the differential equation. So we will have, okay, so m is fixed. M is not the arbitrary constant, so we've already gotten rid of the arbitrary constant within the problem. So we can just rewrite this differential equation by saying y prime plus m squared y equals to 0. Or using the y by the x, we can say the 2y all over the x squared plus m squared y equals to 0. So this is the differential equation of this family of curves that was given. So this is the differential equation. We eliminated the constants within the differential equation, the arbitrary constants a and b, and we have arrived at the differential equation. So thanks ever so much for watching. Please subscribe to our channel. See you in our next video. Thank you.